All right, welcome back. Today we are going to take a look at this case, Lana Goes Ice Skating. Now, if you're not familiar with Excel Esports history, I understand. Lana is a character that made her first appearance last year in the 2023 World Championships, where she's running around collecting bananas on a map. This time around, she's doing the same, except instead of running around, she's skating around this ice rink and collecting bananas on this rink. So we have 7 levels of questions plus 5 bonuses to try. Let's give it a go and let's see how we do. All right, now as we're watching me play, I'm going to describe to you what's going on in my head. First thing I'm going to do is I'm going to create a copy of the map. This is going to be very useful for when I do screw up the data in my first map later, because I always tend to do that. Now for this first level, all we need to do is say what is within that cell. So I'm going to use an indirect function and fill all of those in. I also did a copy and paste values so that those answers won't change between me changing the map or adding other answers in later. Now let's go on to level 2. In level 2, we are given a cell and we need to see within a 5 by 5 range how many bananas are within it. So what I'm going to do is I'm going to take my map copy and I'm going to put in a formula to count the 5 by 5 range and how many bananas are within it. So you see up here on the green space we get 0, and when I fill that all the way down to the bottom corner, now we have our numbers. But you notice something here, I'm still missing that first row and first column of ice. So I'm going to copy this formula, but I'm going to change it a little bit. The reason why I didn't fill it up to that row is because that will create an error. So let me fill in this modified formula in that first row. And let me go ahead and do the same thing here for that first column. By the way, I say first, I know it's really the second. What I mean is the first column in row with ice in it. So there you go. Those numbers were how many bananas were in that range. I'm going to do another indirect function to bring those numbers back into this sheet and fill those all the way in. Now we go to level 3. So in level 3, we begin skating. Lana starts these cells and moved in a specified direction until she hits an edge of a lake or an island. How many bananas does she pick up along the way? So I'm going to start making my model on this new sheet where I pull in the question information or the game information into that new sheet using an XLOOKUP function. Now I'm going to start the model. I'm going to go with however many columns because I can tell there are more columns in this map than there are rows. And we're not going to go farther than that number of columns. So I believe that is 85 columns. I'm going to bring in the cell address into there. And then what I like to do after I bring that in is to bring in the row number and the column number of that reference. That's going to be useful later when I make my movements based on the arrows that we see. I'm going to center it so I can see better. And now I'm going to bring in what that cell actually contains. So we see here in this first cell, it's going to be nothing. Now, I don't like seeing zeros when it's actually nothing. I think they should stay as nothing. So I'm going to replace that with the blank cell. Now let me bring in the arrow. And that arrow is also going to have a number of rows and a number of columns with it. Now these are different arrows than we're used to. So I'm going to bring all of these arrows in together. We have 8 arrows, which is what we need. I'm going to sort them so that they come in order. And I'm going to bring these over to my model. Let me add in a few rows. Oops. Add in a few rows so I have that space to bring those arrows in. There we go. Now each arrow means we're going to move a number of rows and a number of columns. So when we move up, that means -1 row. We move down, that means +1 row. Same thing with columns. Left is negative, right is positive. So I got my table set up here, and I'm going to turn them into named ranges so that when I type in these arrow formulas now, it'll be easier for me to do. So you see that arrow means -1 row. It should also mean -1 column. Now I'm going to bring in the address of the next cell. So I take the row number and column number of the first cell, add in the corresponding row and number of the arrow, and I use that to build in my address. Fill that all the way down. Now we have all the movements that Lana's made. Now, one thing that I should have done is in these green spaces, I should put in an X to tell me that we've hit a wall. And you saw that I did that by using find and replace based on the cell format. So now my model has X's when she runs into a wall. And I'm going to add in a field here that says, when does she stop skating? She stops skating when she hits a wall. That would be move number 8. So the question is, how many bananas will she collect? So she'll keep collecting bananas until she hits a wall. So I'm going to count the number of bananas on this results field. And then I'm going to add in as a second condition, make sure that sequence number is less than when we hit that true field. Misclick there, caused a little bit of errors, but we got it back. And now we get the answer of 3, which is what we were looking for. Bring in all the game numbers for this level in, and we'll turn that into a nice data table, which should get us all of the answers for that level. Make sure they match up, and we're good to go. Level 4. So now this level introduces the concept of turns, which really threw me off for a while, because regardless of the turns, they're still collecting the bananas at every spot along the way. I don't know what really turns added into this, so it took me a little while to get this to show up properly. Now with these turns, we add in the ice crystals. And the ice crystals basically increase Lana's speed for each turn, or how many cells she's going to go over in each turn. So now I'm going to change my model up a little bit. I'm going to add a column for the bananas that she collects. And I'm going to add a column for the ice crystals that she collects along the way. And that will help me know her speed as she's going through the ice rink. So we're going to fill those down. There we go, very nicely. And the tricky thing is that the effects of the ice crystal do not happen until the turn after she collects it. So we see here that on the 29th cell is where she's going to run into a wall, and that's going to end. But what turn is that? I'm going to make the second table to calculate my turns for me. I know I'm going to have a maximum of 85 turns, just like I had a amount of 58 cells to go across. I put my start cell, the speed at the current time. So when we do our first move, the speed is always going to be 1. And then which cell does that turn end, or which sequence does that turn end? So you see start 1, speed 1. And I forgot to add the speed column in my previous model. So I'm adding it in now so I can look that up as I do this turn table. So I'm looking up the speed based on where the turn ended. For the next row, we go start on the next cell, bring that speed down. The last 2 columns were calculated, so we can bring those down as well. And let's move that all the way down through this turn table. Now, she ends skating on sequence 39. Where is sequence 39? It's on turn 14. She goes from 37 to 43. And if we were to look back at the example, 14 was the correct turn for this example question. So once again, I'm going to go ahead and build my data table, which basically says find out where the stop is in this turn list. I'm going to bring in the game numbers over. I'm going to go ahead and run the data table calculation. There we go. Let's see if these answers match. And we are good. So now we're going to go on to level 5, and level 5 includes snowmen. So whereas ice crystals increase the speed, snowmen are going to decrease the speed. So now we have the possibility that Lana will get stuck at some point, and then that's where the game is going to end. So first, let me add in another column for snowmen, so we can do a running count of the snowmen along the way. Now, see, what you might be noticing is I'm copying and pasting values for these emojis. So that way I don't have to try to find it every single time. Other players like to give names to a cell with that emoji. That works just as well. All right, so I got my speed in here. It's going to vary from 1 to 2. I'm going to add in this extra condition for stop, which is when that speed reaches 0. And now let's see where this ends. So we ended on sequence 22. Sequence 22, what turn number does that correspond to? We look at our turntable, we'll see sequence 22 is with turn 19, which is the correct answer that we are looking for. So let's go ahead and create a third data table. Now, I mentioned this in my previous videos. The reason why I delete these data tables is because I don't want them to continuously calculate every single case on every single change of the Excel sheet. So I delete that to prevent that from happening. Doing partial calculations will also achieve the same effect. Let's copy these, bring these over. All of our answers match. That's good. Now we get into level 6. And level 6 sounds trickier, but it's really not that bad. Basically, we have a starting cell, and now Lana can choose the direction. So this is really, you can do this with a very simple two-sided data table. And you're going to see how I'm going to do that here. So I changed in my data input because now it's only one column instead of two. That causes my model to get screwed up a little bit, but I bring in a random arrow. It's going to make work just fine. So I'm going to start my two-sided data table here. So on the left side, I've got my game numbers. On the top, I've got the potential arrows. What is the highest number of bananas that she collects? So I'm going to use my banana calculation. What I'm going to do, I'm going to change up because now I'm doing the running count, right? So I just need to look up where she stops and how many bananas does she have at that time. Achieves the same effect as the countifs earlier, but this one's maybe shorter and simpler to write. Now with the two-sided data table, I have to put in the row input cell, which is the arrow, and the column input cell, which is the game number. And you'll see answers come up very easily. All we need to know is the maximum number of bananas. There we go. Let's bring that over, and we're good. Now, level 7 was the hardest level. And you're going to find that I'm going to struggle in this level as well. Basically, now instead of the games ending at the walls, we're going to bounce off of the walls. And the direction that we bounce is going to depend on where we hit the walls, which is a little bit tricky. But I'm going to do this with some very simple logic. So you see here, if we run directly into a corner, we're going to bounce back 180 degrees. If we run into a side, we're going to bounce off at a 90-degree angle, depending on which side we run into it. And then this last one, you see we're going along the wall, but we're not bouncing on it. So we just continue going along. So there's really two things you need to consider here. Let me delete this move table. We don't need the moves anymore. The first thing you need to consider, I'm going to put these arrows up here so that these give me a mental note of which turn I'm looking at. So the wall directly in front of you, you're continuing in that direction of the arrow. Is there a wall in front of you as you continue in that direction? Now, I copied and pasted that arrow table. I'm going to explain that here in a minute. And this formula is going to look a little bit odd how I have it set up because it's going to have a few plus zeros. But there's a reason I'm going to do that. So what I'm doing now is I'm looking for an arrow based off of the current arrow. Now, when the wall is in front of us, that means we want the same direction. So that's why I'm putting a plus 0 here. For the other arrows, you're going to see that because we're looking at different angles, I'm going to do a kind of a shift in the arrow table. So that's why I'm going to add numbers. So these plus zeros are currently serving as placeholders for me. So I'm doing an address function to get the address of the cell immediately in front of me. And you will see that I do make some mistakes along the way. Like, for example, I forgot to include our current cell column, which is why this formula is not checking out properly. So here's me investigating, trying to find out why. Okay, I put the cell column in. I put it in at the wrong place. It should actually go in front of the second index right here. There we go. So now we have the address for the space in front of us. I'm going to turn that into an indirect so I can see what is the content of the cell in that address. Once again, it brings back a 0 when it's blank, so I'm going to do my leave it blank formula. There we go. Now, That's actually turned into a lot. It looks like a lot, but you saw how I built it together. You probably could have put that in an if statement, and it probably would have worked better. See, now when I modify this, I have to do it 4 places. So now here what I'm doing is, now we're looking at the wall at a 45-degree angle right and to the left. So that means the arrow table is going to have a corresponding shift. When it's 45 degrees to the right, I'm going to go 1 to the right. If it's 45 degrees to the left, you would go 1 left, but because my table is going left to right, instead of going -1, I'm going to go +7. So here now we're getting in, is there a wall in front of me? Yes or no? If no, then keep going in the same direction. Now let's add in for yes. So if there is a wall in front of me, and there is either a wall both on the left and right or no wall on the left and right, we're going to do a 180-degree turn. So to make this simpler, I'm just going to put left is equal to right. Either they're both yes or they're both no. And to reference a 180-degree turn, I'm going to use the index match and an offset of 4. That's going to bring back the opposite direction. Now, if there's a wall to the left of me, I want to go 90 degrees to the right, which should be a +2. When I first put in this formula, I did it incorrectly. But you'll see later that I'm going to identify that problem and we're going to be able to fix it. So let's modify the rest of the table. Oh, by the way, now we have a different arrow. We need different arrow row and column numbers. So I put NAR for next arrow row and NAC for next arrow column. And those name ranges I did earlier work just as well here. Finally, our cell is going to change. So let's update that formula. And let's bring all of these down. And we're going to bring all of these down. Now, if you're looking at it closely, you see that we're still hitting wall cells, which is not what we're looking for. Also, we only have 2 bananas when our example answer should be 12. So once again, I'm going through and I'm trying to diagnose what's wrong. Well, the first thing I notice is that if we run into a cell twice, then we don't need to collect the item a second time. So I'm adding this if statement within it to make sure that we only collect stuff from cells once. But why are we still running into a wall? Well, one of the problems is I didn't update the arrow. So I'm actually going to go look at the map now and just see, does this actually make sense? Is it right that when we do this, we go in a certain direction? And here I notice it doesn't. So remember when I said that I noticed my offsets were wrong earlier? This is where I found that. So now we're going to change this to 2 and 6, which they properly should be. And we're going to fill that all the way in. Okay, now the turns are looking correct. We're not ending in walls. But do we still have 12 bananas? We do not. So here I am investigating some more. Why are these arrows keep going left and right and left and right? That seems a bit odd to me. So I'm going to go look at the map again at those cells. No, they shouldn't be going left and right like that. It's going B32, C33, D32. Ah, here it is. I forgot to update my arrow. We update the arrow. Now the model looks like it's working properly. 85 rows is not going to be enough, so let's bump that up. I'm going to do 500. You know, make sure that we cover ourselves. So there our model's updated to 500 rows. We see as we get to a certain point, we're not collecting anything anymore. So that tells me that we've probably collected everything that we could. So I'm going to start my data table again here. I'm going to start by how many bananas did we collect total, bring in my game numbers, and run through my data table. Let's bring those answers over. I'm going to save to force full calculation. My computer sometimes doesn't do it. Uh-oh. We've got a lot of red. What's wrong here? Why are these not correct? Let's look at game 121. Because 121 was wrong. Let's see here. Okay. Not identifying where it is yet. The problem is I also forgot to consider something else. So remember when I said what is the total number of bananas we collected? I looked way down at that final cell, I forgot to consider speed. So we're not worried about turns anymore, but we are concerned as to when Lana stops skiing. So once again, I'm going to look at this. I'm going to follow the path Lana would have actually taken. I'm actually counting the bananas here. So far, I've got 1. Let's go back to AT where we started. And we go down. There's 2. Okay, well, 2 bananas seems to be correct. She's bouncing at 180-degree angles. What is wrong here? Let's look back at the model. Nope, let's look back at the lake. This did take me quite a long time to figure it out. The arrows are actually correct. So the right side of the model is actually correct here. Now I'm finding the snowmen. The stop is at 0. So here, I didn't consider when the skater actually stopped. So now I'm going to go back to my old banana lookup where I look up true in the stop column and bring back the banana column. Now, I don't know why Excel does this, but when I go into edit arrange, it changes the insert mode. And so like things will get deleted even though I'm not intending to delete them. So now when I'm considering the speed, we've got 1 for 121, which is the right answer. But now we have errors. Well, let's look at 122. Why do we have an error? Well, if we look at the stop column, there's no actual stop. There's nowhere where she hits a speed of 0. So in that case, we want the lowest banana number. Now we have answers for all these questions, and all of them will fill in very nicely. 21 minutes and 20 seconds so far. Not bad. Let's go up and take a look at these bonuses. How many bananas are there on the frozen lake? Well, that's pretty easy. Let's take a look. Copy the whole lake as a range and count the number of bananas in it. That's a very nice, simple Excel formula. How many lake cells have at least one corner touching the outer edge of the lake? So there are probably 2 or 3 different ways you could have done this. What I did was I once again created another copy of the map. And I did this conditional statement. If the frozen lake cell is not an X, meaning you're not already on a wall, and any one of these 9 cells around you is an X, meaning you are a wall, give me true or false. And this double minus sign here at the beginning will turn that into a 1 or 0. So I'm going to fill that all the way in across, and I'm going to just simply add up those 1s and 0s. And that should tell us how many cells touch a wall. There we go. How many cells on the lake have at least 1 banana, 1 snowman, and 1 ice crystal located no more than 2 blocks away? This one was trickier for me. I ran into a few problems while writing this formula. But basically, the strategy that I took for this previous bonus question, I'm going to apply it again to this bonus question. So I'm going to do a range of 5 by 5. I'm going to put it into a let statement so I don't have to rewrite that range every single time. I'm going to say, count if that range contains at least 1 banana. So the count number of bananas is greater than 0. Count if again if that range contains at least 1 snowman. So same syntax here, greater than 0. And count if that range contains at least 1 ice crystal. And then I also want to make sure that I don't count this cell if it's an X, because we're only counting the cells that are on the ice. Now once again, I'll do a double minus, and that will turn that into a number. But once again, just as we saw in the previous, we haven't considered that second row or that second column yet. Those have ice cells, so we need to add those in. So I need to change my formula up a little bit for these two so that we can consider them. So I'm going to start with the B column. I need to adjust the range a little bit. So instead of A1 to E5, now it's A1 to D5. Fill that all the way down. You might also notice I'm doing paste formulas. This is so I can keep the colors, and then I can more easily debug when I see the colors on the ice. So once again, adjust my range. So now it's a 4x5 range instead of a 5x5, because if we were to go off of the sheet, it's going to return an error. All right. Now let's add these together and see what we get for this bonus question. Uh-oh. Another red X. Well, what happened here? Let's take some time to debug this one. Now, if you're looking closely from your screen, if you take a look at cell BB2, you may notice that it is a green 1, which means green is on the wall, but the 1 means it's actually counting it. So that means I haven't made my original reference cells correct as far as are we on a wall or are we not on a wall. So here I've adjusted it, and now the formula calculates correctly. Under the level 3 rules, what is the maximum number of bananas that Lana can collect on the ice? Now, this one, I will have to admit, I cheated a little bit. And we're going to take a look here. So first thing I notice is that this map doesn't have labels. Sometimes I do, sometimes I don't. So I am going to add labels to this map. So I'm going to add column names or column letters here. That's a bit trickier formula. The row formulas are much simpler. It's just the number of the row. I could probably do the number of the column as well. Either way could probably work. So now I'm going to create a table. So I'm going to add all of the addresses in, which is simply concatenating all the columns with all the rows. And I'm going to add these into a toCall function. So this will list them all as one single column. And then I'm going to do the same thing with my results side of the table. So I'm just going to put all of these results and put them into one column there. Once again, these will return zeros if I want blanks, so I'm going to keep them as blanks. I'm going to paste them as values because I'm not expecting any further manipulation on them. Turn them into a table. And if you haven't noticed, I tried to name the table within that pop-up window. There's no spot to actually name it. I have to name it after creating the table. And now I can't use that name anymore. I also cannot use a name that is the same as a cell reference. So I have to add in the whole word bonus 4. Now in this table, I'm going to add columns for row plus column, and row minus column. So I'm going to get the row number, the column number, the two numbers added together, and the two numbers subtracted. The added and subtracted numbers are going to tell me which diagonal they lay on. Now this is where, like I mentioned, I don't think this is the best strategy, because this is just simply adding in all the numbers along a certain row or column. But it's not considering the islands that were in the middle. So here I'm going to pull up all the individual row numbers, how many bananas are on those row numbers. Because this is level 3 rules, we're not considering snowmen at this point. We're not considering that Lana might get stuck. So we don't have to worry about that. Now I'm going to turn it from table references into cell references. So that way I can copy and paste the formulas much easier. So this will tell me how many bananas were in each of those rows. Now I'm going to do this again, give me the unique number of columns and how many bananas were in each column. So I can easily copy and paste that formula and just make the small adjustments that I need to. And we're going to do the same thing with the two diagonals. The reason why I didn't fully answer this question was because I was worried about how many calculations it would have taken if I tried to do a data table. I think it said there were about 3,000 border cells, and with 4 different directions, that means 12,000 calculations or scenarios that you'd have to consider. And I don't think I'd be able to do all of those. So now I'm just taking the maximum number of bananas from each of these row, column, and diagonal numbers. And we do get the correct answer of 14 here. But I would like to hear from anyone else if you have a better way to solve this. Now we have a new rink, a 12 by 25 rink. Lana's going to set off diagonally from the top left corner. How many walls is she going to bounce off of before she returns to her original cell? So I'm going to create a 12 by 25 rink here. I'm going to use the same X's to denote the walls because that fits into my current model very well. So I'm going to start by 14 by 27, so I have walls on each side. Create the walls using capital X's, and then leave the space inside blank. Now I go back to my model. I'm going to have to make a few modifications to the model. So for example, I don't need to bring in data from another sheet now. I can just simply paste the data in myself. So we're going to start, I will fix this. We should start in B2, not B1. We're not going to reference the frozen lake sheet anymore. We're going to reference the B5 sheet. You may notice that it come up with a ref error because I didn't do the syntax properly. So now I'm just going to change it in everywhere the sheet name is found, because you probably notice it's a lot of times in this worksheet. 3,998 replacements. If I included the replacements I made in the first place, that's exactly 4,000. All right, so my syntax here is wrong. I need an exclamation point between workbook name and cell, or worksheet name and cell. I see that I'm starting with an X, so I need to change that to B2. And now we got all the movements in properly. So we bounce off of a wall when we hit an X. And you may notice that every time we hit an X, we're actually hitting two X's. But two X's should only be one. Here I'm looking to see where Lana will stop. So you notice I put the stop formula as when she hits that same cell again. We didn't see it in the first 500. So now I'm going to do it again for 1,000. And let's see if we can find where she stops. Search in values. And we see it here on move 529. So I took this extra step of deleting all the extra moves. Probably unnecessary. But this will help me in my wall calculation, as I mentioned earlier. So let's go through, and at every turn, let's count how many walls she's hit. Remember that when we see two walls, that means she's only bouncing off of one. So we need to subtract one. We also don't want -1 when we don't hit a wall. So I'm going to put a maximum of 0. So it can't go below 0. I'm also not counting the two walls she hit at the end, because the question says, how many times will she crash into a wall before returning to the same cell? So now I'm going to add up all of these numbers here. Boom. 1,250. Solved it in 32 minutes and 21 seconds. That was tough. That was very tough. But I hope that you guys got a lot from this video. If you have some other strategies to solve these questions, I would love to hear them. Share them in the comments. I'm going to link a few other videos where you can watch this. Thank you for taking the time to watch me, and I'll see you for the next video.